Hello, 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 and welcome to our new Five Nights at Freddy series. This will be a two-part series, and today we will be doing part one. Please make sure to leave a like and subscribe if you like the content, and I'll see you soon. Alright, let's get started. So, in this scene already, I already have like a ton of sprites that I'll use for the game. Link will probably be in the description for all of them, but I'll use this throughout the video. Feel free to use your own thing though, so because this is mainly just art that I made in like 5 minutes, but I'm sure you guys can use it if you like. Alright, so we're gonna try to do a background game object. This will be like the office area and like the view from the cameras, pretty much everything in the game that we'll have in one image. So we will use the office. Yeah, here we go. It's the one of the this one. Make it pretty large. This is to enable scrolling. So we'll get it aligned with the camera vertically but not horizontally. So it looks like we're gonna have to scroll through the office to get to places. I believe we'll do a 2 and 1. -20. Each button will go here. I'll name the buttons as well. So this is going to be light button L, door button L. Then we'll have one for the, I believe that's the hallway. We'll call it flash button. And then same thing for the right door. And then this one. Alright, we'll make all these a child of the background. And then after that, we're going to make our camera thingy. This will be a canvas object, so you can access it anytime. So create empty. We need just image. UI image. I'll call it camera icon. Alright, camera's here. We're gonna have to center it a bit. Alright, there we go. You can center it like that by doing Alt Enter and clicking the bottom. Not Alt Enter, Alt Shift and clicking this part right here. Alright, that's the office. Now we're gonna move on to scrolling. Alright, let's make the office movement. So we're going to need a new game object. We're going to call this scroll area. And we'll need one for the left and right side, so we'll do scroll area L for the first one. We're going to give it a collision area, so box collider. And then we're going to move this all the way to the left side of the screen. And we'll expand the box collider. So now it'll fit the left side of the screen. Or I should say the camera, which is what we're doing. And then 25. Then we'll need one for the right side, which is going to be the same one. Alright. Let's make a new script. It's going to call it scroll area, and yeah. There's a few things we need to do here. So one of them is make the background, give the background a reference that we defined earlier. And another one is we're going to have to do a new function called onMouseOver. So this will run when our mouse is over this script's box collider. And then we'll call if, actually no if statements right now, so background.transform.position equals, then we'll do new vector 2. Alright, we'll need a public float for the scrolling speed. Then we'll do background.transform.position.x plus scroll speed, and then background.transform.position.y. So what this code does is that every time the mouse hovers over this scroll area, the position of the background object will update, and it'll update by the current position plus the scroll speed, while keeping the Y position the same. Back into the editor, if you notice that if we move the background, moving it this way, which is technically right, actually moves it to the left, and moving it left technically moves it in the positive direction. So when we do the scroll area for these two scripts, it's going to be sort of backwards, so we're going to drag in the reference of it. But the scroll speed for the left side will be a positive small number, and we'll drag in the reference here, and the scroll speed will be a negative small number here. Let's test it. As we can see, scrolling works pretty nicely. But I don't know if you saw it, but you can pretty much scroll infinitely and the camera goes off screen. So we're gonna have to fix that. So in the code we'll have to define a few more things, and one of them is a sort of bounds, so the scrolling doesn't happen beyond the background image. So we'll call this scroll bound X. And depending on which object it is, because both the scroll area left and right use the same script, we'll probably need a way to distinguish the two. So I'll make a public boolean called left. It'll be true if it's the left scroll area and false if it's the right one. And in here we'll have an if statement. It'll be if the current position of the background dot x is, since the opposite, I believe it's less than scroll bound x, and this is going to be the left side. So if it's less than it and left side is and you're on the left side of the scroll area, then keep going until it's greater than the scroll bound x. And then we'll need a else if background position dot x, and then the other way around now. So if it's greater than scroll bound x and not left, so the right, then we'll do the same thing here. So same deal here for both of these. You may have also noticed that we could have just done this. Just do a, have it in parentheses and do it in one big and statement, and then do it like this. Actually, no, it'll be an or statement because else if, but so it'll be left or that, but either way works. So yeah. Alright, let's set the scroll bounds. So we'll have to demo a bit for this, but this is the maximum side that the left scroll can go. It'll be about like 24, so left side will be 24. And the right side, if we move it around it'll go all the way to about 14, 15, minus 15. So we'll do minus 15 for this one. Alright, let's test it out. Alright. Say we cannot scroll left anymore, but okay, right seems to okay, well. Big bug, let's see what happened. Okay, so I realized I never checked the left boolean for the left scroll area. And now if I were to play this, it works just fine. So left side, you can't go any further. And the right side, can't go any further than this, but it's a little off. So if we were to do minus 14 instead, then it will be just fine. Okay, that's good. Awesome. Alright, so let's make the buttons. Here we will add the box colliders to the buttons. As so, and then we will add another thing, which is going to be a new script. We'll call this office button. Oh, I missed the button, but we'll need to add a box collider and office button to that one as well. Before we start with our office button, we will make a new game object called Game Master. And in this script, we'll also call it Game Master. I've also added these little doors on the left and right side of the office. They do nothing right now, but they have two animations. Left door close and left door open. And the same two animations for the right one, but it's going to be called right door open and close. One thing I did make sure to do is to set them with their loop time to false. That way they don't repeatedly loop over and over again. So both of these animations have those. All four of them do. So if I were to run the game, they would not loop through the animation. They would just have the door opening animation playing. I've also noticed that the scroll areas are covering the buttons in terms of the huge box gliders. So one way to fix this is to turn on the 3D option and then move the buttons forward a bit. So in this case, I've moved the buttons to be -5 on the z-axis, and that's for every single button. Alright, so the Game Master will work as sort of a universal reference to every script in the game. So every script can reference this class, and we can do that by using a public static Game Master. We'll call it instance. This makes a new instance of the class that's static, which actually means dynamic in like programming terms. So that means that any script can reference it if it uses this field. And we'll make sure it references the right version of the class by doing awake and then private void awake. And doing instance equals this. So whenever the instance is made, it'll immediately be defined to this version of the class in the awake method. And the awake method runs before start, so that'll pretty much run before any references to this class is made. In the office, we have quite a few rooms. We have the standard dark office, as well as the office with all the lights on, the office with only the left light on, the office with both left and right lights on, office with the middle light and the left light on, middle light on, etc., etc. So, one way to add all of these backgrounds in the game is to make a public sprite array called backgrounds. This will hold all the backgrounds that we've described before. And then to access them better, we will do a public dictionary of string sprite, and we'll call this background dictionary equals new dictionary of that same type. So if you guys don't know, a dictionary is basically an array, but instead of accessing values with a number, so in a typical array, say this is a array, and its name is foo or something. So if you wanted to access the second element of the array, you do like foo of 1. In a dictionary, if this was a dictionary and then these were the values and they were associated with like a key, say this is like some random digit, not digits, but strings, then if you wanted to get 10, you would just put PQ. So you do foo of PQ, and that will give you the value 10. So it's the same thing as an array, but instead of indexing by the number, you index by whatever key is given. In this case, our key is a string, and it returns the value of sprite. We will initialize the dictionary by in start, we will do a for each loop to loop through all of the sprites in the background. So sprite in backgrounds. We'll do if, oh actually we don't even need that right now. We will just do background dictionary dot add, and then we'd simply do the not background, but sprite dot name. That's our key. It's going to be a string. It's going to be whatever the sprite's name is, and our value will be the actual sprite itself. So this will fill up the dictionary with all the backgrounds, and we can easily look up every single background in the game by just finding the name from the dictionary. So if we wanted to get the office with no lights on, we would just simply do background dict of office. And then that will just return the sprite of the dimly lit office. We'll also need something to check which lights are on and which lights are off, as well as which doors are closed and which doors are open. And a decent option is to use a generic list of string, and we will call this a lights, signifying all the lights. And this will be a list. It'll have either be empty, which means no lights are on. It'll be an array with just left, meaning only the left light is on. Or it can be left, middle, right, which means all 3 lights are on. Then we'll need something else for the doors. We'll call it door. Yeah, and then this will be empty, left or right, no middle because only the left and right doors exist. Lastly, we'll need the current background that we're on for the game, so we'll do a public sprite cur background. Now we will try to put all this together. We'll need a public function, so we'll do public void. It's the turn on lights. Not technically returning off lights, so check lights I will do. Then. Alright, so there's a lot of different combinations for this list that we're going to work with. So I will put down here, it can either empty, left, middle, right, no duplicates, any combination. So we'll need to check which like elements are in this list. An easy way to do that is to check the count. So we'll do if lights.count is lights.count is greater than or equal to 3. If it's greater than or equal to 3, it has to be left, middle, right. So that means that our current background will current background sprite. Oh, okay. Well, this is not a sprite, but a sprite renderer because we need to render the sprite on the screen. So we'll do current background dot sprite equals the, and since we can look up the background by name with the dictionary, we can just do background dictionary of the whichever name all three of the lights were. I'll have to look back on this, but I think it was office lights all. And then, so that's if there was all three of them. So I'll put this down, all 3 lights enabled. We will need another one. This is if, I'll need curly braces here, but 2 lights enabled. So else if lights.count is equal to 2. And then we'll do one more else for if it's 1 light enabled. 1 light enabled. Okay, so for 2 lights enabled, we know that there has to be one element missing from the array. It can either be left comma right, left comma middle, or middle comma right. So we know one element's missing from every single one of these possible arrays, so we will do a if statement for if the lights does not contain the left. If lights don't contain the left, that means that it must be middle right, because that doesn't have left in it. So we will set that background to be that. So now this will be middle right light, and we'll do else if lights does not contain right, that means it must be middle left. So we'll do middle left. And then we can just do an else here. So if it's not left or right, then it's probably this one. So that's the only other possibility. So do that it's going to be left, right light. All right, so that's for 2 lights on. And we already did for 3 lights on. Now we only need if there's only 1 light on, which means that we should probably just copy and paste this, but have that it contains 1 element. So if it contains left, if it contains right, and then have an else statement for the same thing. So if it contains left, we'll do office left light. If it contains right, we'll do office right light. And if it contains something other than left and right, it's probably the middle, so we'll do middle light. And then one more thing we didn't do is if there's no lights, which means an empty array, we'll just have a check right here. If lights.count is less than or equal to 0, then we should just set this to be, leave the dimly lit one was office, and then after that it's going to be, we're going to return because we don't want to run anything else if it's empty. And that's what return does, it just returns out of the function. and onto the next line for whatever calls this function. So I only messed up one name here. This is Office All Light if you're going by the original sprite names in the project. Alright, we're going to add the functionality for the doors too. It's very similar, so do it here, public void check doors. Alright, so we're going to do a if doors.count is greater than or equal to 2. Then we're going to set the we're going to play the animations now. So that'll do left door dot play. I think it's like left door close. And then we'll also play the right door because if door counts 2, that means both left and right doors are closed. So do left door close and right door close. Else if doors dot actually we can just do else if doors dot contains left. Then we'll do one closes and the other is opened. And then we'll do an else. That means it must be the right door that is only open right now. So we'll do left door play. I don't know why I typed this out, but do right door dot play. And then one more for if the doors are like there's no doors. So if it's listen equal to 0, then we will set the actually yeah we didn't do that yet, so we'll do both of these are closed. And we'll return just like above. I meant to have this one as closed, by the way. Actually, no, I lied. I meant to have this one as open and right as closed. Alright, let's see if this code works. We're going to add every single background in the game real quick to the backgrounds sprite array. So we'll add all of the offices here as such, and we'll also add the different camera areas. Box den, kitchen, dining area, right hall, showroom. I think that's all of them. 2, 5, and left hallway 6. Alright, so that's every single background in the game. And then our current background is actually the one we have right now, so we'll drag background in. And then our left and right animators are for the left doors and right doors. So left door animator, right door animator. And our lights and doors are good here. We'll use them for testing. And yeah. For our buttons though, unlock this. Our buttons, we're going to have to set its type for each button. So this type is going to be, it's going to be lights, and then location is to the left. This one's going to be a door, and this one's location is also to the left. This one's lights, and its location is middle. This one over here is right, no, lights, and its location is right. And this one over here is door, and its location is the right. Alright, let's test to see if this works. Here we can turn on the lights, close the door. Can I open the door? Probably had the wrong animation. turn the lights on, and turn the lights on. Close this door and open this door. Interesting. Alright, so let's test if multiple lights can be turned on. So this one and that one. So both lights are on right now. And if you want to look at the in-depth of the code, we can see that the left and middle are on right now in the array, and the left is on for the door right here. So, and if we remove the middle, it'll only have the left one. And if we did the right, it'll have left, right here. And then if we were to, okay, well, I think something happened here, but if we remove the door, it probably will be empty. Yeah, so if none of the doors are in here, then that means the left and right doors should be open, not closed. So if I run that, both doors are open now. So if I do boom, boom, and this one, yep, both of them open and close nicely.